Good morning, good evening, good afternoon, depending on where you are. Today it is October 13th, and it is another instance of SIG Apps bi-weekly calls. My name is Maciej, and I'll be your host today. I'm joined by Ken. Quick announcement, the enhancement freeze is approaching quickly. It is happening this Thursday at the end of the day anywhere, which for some of us means it's halfway through Friday as well. So be aware of that. Um, if your cap wasn't looked at by the SIG leads, feel free to reach us on the Slack channels or in a DM. So that was basically all from the announcement, and we can move to the main discussion point, which is the checkpoint restore working group. And Rodostin is already sharing his screen, so I'll let him speak.
Okay, thanks so much. And essentially, this is the main purpose of this discussion is to get feedback on the working group. So this is a new working group proposing how to essentially how to extend Kubernetes with support for checkpoint restore. And the way this works is we have integrated a tool called CRIU, Checkpoint Restore User Space, with the container runtimes. So, for example, containerd, CRIU, but also at low level with runc and crun. And we essentially implemented a kubelet checkpoint API that essentially allows users to send HTTP requests to the kubelet, and then this will create a checkpoint of the container. So many people essentially, for different people, checkpoint means different thing. But in our case, it's transparent checkpoint, which means it contains a snapshot of essentially everything that runs in the container. So this includes all open file descriptors, processes, and network connections, and etc. So some of the main use cases that we were looking to discuss are essentially fault tolerance. This is, for example, very useful for long-running applications. For example, machine learning training is one of those examples where essentially we enabled GPU checkpointing so that you can periodically create a snapshot of training jobs. And then if a failure happens, you can restart from the last checkpoint. Accelerating applications is another common use case. For example, Java applications often take a long time to initialize, and users can create a snapshot after the application has been initialized, and then use this snapshot to essentially start the application faster. Preemptive scheduling is another common use case where, for example, when pods need to be preempted by the scheduler, for example, to schedule higher priority jobs, we can essentially create a checkpoint of the containers that are being stopped, and then we can use these checkpoints to resume the pod on a different node. And then load balancing is also a common use case where essentially you can distribute the load by, for example, migrating workloads from one node to another. And the main use case that we started the checkpointing feature was forensic analysis. And we chose this use case mainly because it's very simple. It requires only the checkpointing functionality. Essentially, if there is a cyber attack, for example, many financial institutions have compliance requirements where if there is a cyber attack, they need to be able to investigate what has happened. And essentially, this allows you to create a snapshot of everything that is currently happening in the container. So, for example, if the attacker has compromised an application and they manage to terminate the container, you can preserve some evidence of essentially what has been happening at that particular point in time. So we have a few tools that allow you to analyze, for example, the memory pages, and if there is an SQL injection, you can see what query the attacker has been sending. But these are some examples of use cases for essentially what this functionality can be used for. And so what we currently support is creating checkpoints of individual containers. And as the essentially first phase of the working group, we're planning to essentially extend this functionality to be able to checkpoint pods, so not individual containers, but whole pods. And we have had some discussions on how to implement this, but this is one thing on our roadmap. And then the next part will be to essentially um, extend this to be able to essentially have APIs that allow users to checkpoint pods and containers on different nodes in the cluster. So you don't have to do this at kubelet level, but you can use, for example, the API server so that you can create a checkpoint on any node in the cluster. And then the integration with different tools like queue and autoscalers and essentially other use cases. And we have also discussed, for example, how to enable encryption. So the idea is that when you create a checkpoint, this checkpoint contains a snapshot of the memory pages. And this could, for example, contain sensitive data, for example, passwords or user data. And essentially what we want to do is want to enable end-to-end encryption so that the data is encrypted before it is saved to disk. And what we're trying to do is we're extending the checkpointing engine, so in this case Creo, to essentially encrypt the memory pages before they're saved to persistent storage. And we're also investigating how to essentially compress these memory pages. And this is related to the encryption feature. Essentially what we want to do is we want to compress the data before it is encrypted. And we also discussed, for example, one of the challenges with live migration is when we have an IP address associated with a pod. When we migrate this pod, essentially we have to preserve the IP address because essentially the clients will continue sending packets to this IP address. This is currently a challenge in Kubernetes. And then we had some discussions on adding resource quota, for example, for limiting the number of checkpoints per namespace or per project. And this is more like for the integration with Kubernetes. But in general, we're looking for feedback on the working group, and we would be grateful for any essentially any advice on how to move forward. I can stop sharing my screen, but
Yeah, go ahead, Ken.
So are you looking to do wait, can you guys hear me? Okay, good.
um,
My little mic is not going. So are you guys looking to do checkpoint and restore or migration or both? You're
kind
not
of both. Yes.
okay. Um okay. All right, I guess that's a lot. So how can we help? Like, you want us to give you feedback on whether you should do a working group? Like, are you looking more specifically, what kind of help are you looking for?
Yeah, I mean, so we have this pull request for the working group, and what we need is approval from SIG Apps chairs, from the SIG App leads. And essentially, this will allow us to move forward and create, for example, a Slack channel and mailing list and all these other things, and essentially start having regular meetings to discuss the implementation of different features.
Do you want SIG Apps to sponsor the working group?
Yes.
Okay, that wasn't clear to me. Why SIG Apps as opposed to, like, I mean, this is going to touch on a lot of things. If you wanted to do this, so right now the checkpoint and restore stuff is only exposed via the kubelet APIs, right? So like it's kind of in kubelet already. That'll work. I'm not sure, like I actually don't know if it only supports Creo or if the checkpoint and restore functionality in container D can be exposed via the kubelet APIs. Do you know?
So we're I mean, I know that Containerd has something called Snapshotter, which is for storage snapshots, which is different, but also has checkpointing functionalities. What we use. So
Right.
yeah,
But does the current kubelet API work with container D as well as Creo or just with Creo?
both Cryo and Containerd.
Okay,
Yes.
that I didn't know. When it initially launched, the container D support wasn't there yet. Like container D couldn't do checkpointing at all at that point. Like it was kind of broken and half merged. So we have a couple of runtimes where it works. That's in kubelet. So I think the primary things that would need to happen is figuring out APIs. So is it? Do you think SIG Apps is the right thing because you think the way this works is via the built-in controllers, or you need new controllers for workloads in order to make this work?
So we had discussions with a few other meetings, and essentially one of the questions we often have is, for example, whether it would be possible for the application to trigger the checkpoint. For example, if you have a training job, you want to create the checkpoint at the end of an epoch. And this type of essentially how to design your applications to be able to use the checkpointing functionalities, one aspect. But the other one is, for example, what type of applications are suitable for checkpointing. For example, when you have established TCP connections, for example, server with clients, you have to choose whether to preserve these TCP connections or you want to close them. For example, if you're implementing fault tolerance, then you'll be using this checkpoint to resume, for example, an hour later. You don't want to preserve the TCP connections because they will be, that they will not be relevant. But if you use this for live migration, for example, then you want to preserve that. So you have different types of configurations. And one of the suggestions on the pull request was to essentially create the guidelines for best practices on how to use the checkpointing functionality.
Yeah, and so I actually think some of those, like machine learning, I think is somewhat of a straw man. Typically, when you're running ML jobs at scale, you do checkpoint, but you checkpoint to persistent storage. You don't checkpoint DRAM. Like I don't know anybody who actually does that. Like that's whether they're using Slurm or Kubernetes, checkpointing memory pages is not typical of what people do. I mean, that would be a feature you could put out there for them. I don't know. That might
So
be challenging based on some of the existing machine learning frameworks and how checkpointing works.
yeah, so there is a paper from Microsoft where essentially Microsoft have integrated this tool, Creo,
They're doing
into their internal infrastructure, and they use this for something called just-in-time checkpointing. So they don't implement periodic checkpoint, but essentially when a failure happens, they use the checkpointing functionality to, for example, use the state from other GPUs and then essentially create a snapshot that allows them to resume the failed job, essentially to recover the failed job. It's a paper that they published earlier this year, and in
It's,
2022
it's
they
it's effectively at a research level at this point. It's not considered an industry standard. Like it's not most people who are training are not doing this today. I guess and I don't have a problem with that. I don't know if that's the strongest case. Yeah, I guess Magic. Do you have thoughts? Like I don't have an objection to hosting it under SIG apps. I just think it's a very like how to integrate. So what's been done today in terms of I can go curl into kubelet and for the purposes of forensic analysis, I can checkpoint the container, I can pull it off, and I can restore it using Creo or Containerd, or potentially push it as a non-standard image to a registry and then restore it using again Creo or Containerd specifically. That makes sense. I get it. For other use cases, like if you want to try, so like if you're doing live migration, you have to actually swap the DRAM pages on another node in real time, and you have to do IP address migration and all that, which like there are a bunch of other things that have to happen there that aren't just about checkpoint and restore of the container itself. Um, so, I mean, that's pretty broad. I don't have an objection to hosting it in SIG apps, but I think it's kind of a bigger conversation than just what happened here. Majek, do you have
yes. So migration is also a quite interesting topic. So we have multiple different optimizations. Essentially, we have pre-copy migration where we can essentially create periodic checkpoints, and then essentially we can reduce the downtime during live migration. And we also have something called image streaming, which essentially allows you to transfer the pages directly from one host to another without saving them to local disk. Essentially, these are further topics that are down the line. For the working group, it's mainly we had a talk at KubeCon earlier this year, and after our talk, we received essentially many people reached out to us to essentially ask how to use this functionality in Kubernetes, and they suggested to create this working group, and this is the reason we are doing it.
So in general, the working groups that we sponsored in the past were somewhat tightly coupled with the work that falls under what we've been doing under the SIG app. So the batch is basically a portion of the work that SIG Apps is looking at. The same applies basically for the AI integrations or node lifecycle because it affects the controllers that we primarily own. To looking at your proposal, and I remember reading um, through that particular working group, I don't think there's anything directly affecting us because as Ken mentioned and as you were talking, basically you will be touching the kubelet API, which it seems you already started working on. So I would expect SIG node be there, and I see it's there. SIG scheduling, maybe, possibly. I'm not 100% sure about that. SIG auth definitely because either SIG auth or SIG security, because it definitely will affect. It will be in most cases highly privileged operation for checkpointing because you're basically getting the entire state of the container as is. Probably SIG API machinery because you will be exposing the API. I remember hearing about it a little bit earlier that you are planning to expose this through Kube API server. But in my opinion, I don't think there's anything directly involving us that we would have to be um, that we would have to sponsor that particular work.
So we had a few presentations before this one. So we
Hmm?
present the not lifecycle meeting at SIG SIG scheduling, and SIG API machinery. So pretty much everyone except for the SIG API machinery confirmed that they can sponsor us. The working um, and essentially, there were a few people on the pull request suggesting to come to present in this meeting, and that the SIG apps will be.
Okay. So I think you're misunderstanding me. I'm not saying that we cannot sponsor. What I'm saying, we don't have to sponsor you. It means you don't need SIG apps.
You don't need our permission, but we are happy to help.
Yes, that's roughly what I was trying to say. You can literally remove SIG apps from your proposal, and if the remaining six already approved the PR, then the next step for you will be just ping steering committee to have another look at that particular proposal, because at the end of the day, it will be the steering committee that will have to say yes or no towards your working group proposal. And one of the preliminary requests from the steering is usually to get the approvals from all the sponsoring SIGs. So what I'm basically saying, SIG Apps doesn't have to be the sponsor for this particular one. We can
I guess
observe and see, but yeah, go ahead,
I
Ken.
guess yeah, my only question would be this. Do you anticipate like trying to integrate checkpointing directly in with workload controllers?
Um, to be honest, I have to. So one of the use cases for the application, as we discussed earlier, for the application to trigger the checkpoint, and to create different policies. For example, when you have applications that have a very large memory state, you don't want to create the checkpoint very often because then this will create, essentially, this will take all the disk space. And then if you have applications that don't, for example, don't have a large memory state, but for example, consume a lot of CPUs, then essentially the overhead of checkpointing is very important. So, for example, decompression might be challenging. Essentially, you have different requirements for different work types of workloads, is what I'm trying to say. So it's kind of complicated to create a generic policy that works for everything. So it's likely that has to be something that is workload specific.
Right. So I guess if you so do you think workload specific as in Kubernetes API workload resource specific or workload specific in terms of this has to work a particular way with a particular application? Like I would never want to snapshot the DRAM of a relational database management system, for instance. There are other mechanisms by which I can get it persisted to disk. I may be interested, like if it gets to a point of live migration, being able to take hitless downtime for node migration to be able to move that workload to a different node. Like that is a thing, right? There are other ways to do that today too. So I guess like, do you picture it that like we need to figure this out for the category of things that are relational database management systems, the category of things that are base storage systems, the category of things that are batch jobs that are particularly CPU intensive, but maybe not as DRAM intensive, maybe more storage intensive. Like, is that the way you're looking at it? Or is it like, I need to figure this out for stateful set, deployment, index job, cron job?
No, no, it's more like the first case where we have different types, essentially different types of workloads, and the main what we're trying to do is find out what are the requirements, essentially what are the main users of this functionality and what features they would need, and then figure out what APIs we would need to implement to enable these features. So, for example, if you need an API to enable encryption, an API to enable compression, and as, for example, set the periodic checkpointing, for example, the frequency of checkpointing and this type of.
Okay. So I guess maybe the point is that we should be on the list because, like, in terms of understanding how applications interface with the larger system via the workloads, APIs, and other constructs, traditionally that's been SIG apps. So I can buy that.
Yeah. And I think,
I don't see a problem moving forward with a working group to explore further. So unless
yeah, and I just, because I saw that Philip is here on the call, I remember that Philip was discussing with Victoria, essentially extending the eviction API with support for checkpointing. I'm not sure if Philip, do you have any comments?
Yeah. So like the eviction request API we are proposing is like basically for it could be like the trigger for a checkpointing. Like if this gets used in the ecosystem, then it might be available for the checkpointing feature.
Yeah, thanks. And I remember that Victoria mentioned that she wants to write a use case or a user story on how this can be used. And yeah. But the other thing is there are a few startup companies that are essentially trying to use this functionality in production. Essentially, yeah, there are quite a few people interested in how to use this with machine learning applications, mainly because it allows you to reduce the cost by essentially reducing the time to recover from failure. And then with inference workloads, you can essentially swap between different workloads. So if you can use fewer GPUs to serve larger number of models. But yeah, these are some use cases that we were exploring.
Yeah. Can I ask you to act that work group PR? I'll send you the link
we're
because
here.
I'll be then going as a steering and probably acting separately.
It's 80885, right? Or
Yeah, 88508.
yeah.
I'll send it. Or I'll send it. I sent you that also on Slack. Cool. We'll make sure to so you're unblock, and then the next step will be steering, and I'll follow up with the rest of the steering to make sure this is looked at.
Thank you.
Cool. I believe that was the only. Sorry, I believe that was the only topic for today. Thank you very much all for today, and see you in 2 weeks. Bye, folks.
Thank you. Bye.
Thank you.